hinting that that might have a Spark operator component to it, but I'm not sure. So I'll let Kyle share his screen and walk us through that now.
Hi everybody, thanks for having me. Can you hear me fine and see?
Yep.
Okay, cool. So one of the things I work on the storage view, primarily on Ceph, but I've been working a lot with kind of big data applications over the last half. And obviously we're interested in the intersection of Ceph object storage and RAD analytics and OpenShift and that sort of stuff. So one of the things I've been recently working on is kind of building together like almost like a tutorial for experiencing Ceph object storage and learning how you can use Ceph object storage with some of the tools that are coming out of RAD analytics. So if you're interested, you can do this on your own time too by just kind of cloning this repo that I have here. Really kind of cobbled together in this last week, so it's improving. It runs all in OpenShift, and kind of the idea is there's kind of like a micro Ceph called Ceph Nano, and I have kind of a configuration here that'll create a set of credentials and use OpenShift secrets to store those credentials, and then create kind of a stateful set running like a single pod Ceph cluster effectively. That's just just described here. And during the bootstrap process of that Ceph Nano stateful set, it will use the credentials from the secrets to kind of create an additional set of users. So I have right here in my mini shift running on my desktop here, a Ceph cluster consisting of one pod. In a more kind of robust environment, there's the work around, a Ceph operator using Rook, and you'd probably want to do that in kind of a real environment if you wanted to be running a more production grade Ceph cluster inside of OpenShift. But that's still very much pioneering work as well. But really kind of the goal is to be able to use Ceph object storage just like you would use or on-prem. You use Ceph object storage just like you would use Amazon S3. And one of the challenges I had with kind of using that is I was using the S3A connector from Hadoop, and kind of the pre-canned images when I was initially playing around with or the OpenShift Spark images from RAD Analytics were using an older version, or was Spark with an older version of Hadoop, and that was kind of problematic. But one of the new things that came out of the RAD Analytics community is the ability to, or they're publishing these incomplete OpenShift Spark builder images that you can create a build with and provide a tarball, basically a link to a Spark tarball, and it'll create a custom OpenShift Spark image for you with that particular version of Spark. So I kind of put together a Spark, the latest Spark, and Hadoop 2.8.5 tarball, and then I'm using that to create a build here of OpenShift Spark, and then I can go ahead and use that resulting image as the base for a notebook here. So build out the notebook, and then load the secrets, the credential secrets, expose those to the notebook, and then I'm just going through all this verbally so that we don't have to wait and watch all that, so that we can spend most of our time kind of spelunking through the actual notebook. I did that earlier here, loaded it up. So I have the notebook here. Through the environmental variable, I included kind of the notebook in this particular repository, and it's getting the RGW endpoint kind of from this shelled out command here. kind of the most straightforward. If you are just working from within a notebook and you want to interact with the object store, Bodo is kind of the AWS library of choice in the case of Python. So if you kind of want to be able to interact with an object store, it's really kind of as easy as installing Bodo and then creating a Bodo object to interact with the object store. This particular image, I'm just using the base notebook image, and so it doesn't include Bodo 3. You can always install Conda packages from the notebook, but if you do this a lot, you might want to build your own base notebook image. The secret key and the user key, the credentials for the Ceph cluster, and then the endpoint are specified in as I'm creating the Bodo object here, and those are being sourced from the environment. They make their way into the environment from right here. I had created the OpenShift or Kubernetes secret and then exposed it to the notebook. So if you look at like the configuration for this application, you have the endpoint here, which was being passed to the new app command line, and then the secret or the user key and secret key are coming from OpenShift secret and being exported to that environmental variable inside the pod. So instead of having, like, it would be very bad hygiene to kind of have your S3 secret key and a user key kind of like statically coded into the notebook. So this is kind of the current best approach that I've found, at least in conjunction with the Ceph object store. So we have this object now, and we can use it to create a bucket in the Ceph Nano object store. So we have the Ceph object store running in OpenShift here, and then created a bucket, and then just wrote kind of a dummy object into that bucket, and then listed the contents of that bucket. So we can see that there. Now that's all fine and well, but if you're using Bodo just within the confines of the notebook, that's obviously not a particularly scalable approach, depending on what you're doing. And so if you have to do some more heavy lifting and interact with the object store, that's kind of where Spark comes in. So you can, from this notebook, I can create a Spark context here. Of course, it's just talking to the, it's running Spark locally within the pod that's running the notebook. This could, be like a cluster you provision with the Oshinko, or like a Spark operator, I suppose. I'm not particularly familiar with that yet, so I'll have to learn more about that. And then with S3A, you have to set, there's a number of things you need to set, similar to as you had to set with Bodo. Again, we're setting the endpoint and then the credentials here, but we're also telling it to use path style access. Kind of by default, the AWS Java SDK is going to try to use like the CNAME notation for accessing the S3 API, which means you need to kind of have a bunch of DNS plumbing set up that in the case of the Ceph Nano running in OpenShift, we don't have. So instead of using kind of bucket.endpoint/object name, we're going to use endpoint/bucket/object. That's what path style access sets true does. And Ceph Nano is not configured to do TLS, so we're just setting that false as well. If you had kind of a real proper setup Ceph cluster and you're local environment that's available to OpenShift, you would, of course, not have to set those two things. So we'll go ahead and set them. And then that same object that we wrote with Bodo, we can read in the data frame using Spark and by extension the S3A file system client from Hadoop Common. Now, one of the big reasons I wanted to use the Hadoop 2.8 and why I built the custom OpenShift Spark image was it allows per bucket configuration of where I can have a different set of credentials or a different endpoint for different buckets. So right here, I'm drawing from one of the tutorial, the RAD Analytics IO community tutorials. They have some data that they've made available in an Amazon S3 bucket, kind of showing how you can interact from the same context with data both in the public cloud and the private cloud, or public object store, private object store. Here I'm saying that the bucket RAD Analytics -data has a different endpoint than the default that I set here. And that endpoint is Amazon S3 proper, so S3.Amazon AWS. And instead of using kind of the credentials that we configured for Ceph and are coming into the environment through the secrets, we're going to use the anonymous credentials provider because the object assets that we're going to interact with are set publicly readable. And then we can use S3A, and in this case, it's going to talk to S3 instead of Ceph Nano, and load into a data frame a Parquet file that's in that RAD Analytics data bucket in Amazon. And once that's read in, kind of showing the power, what you can do here is you can write it back out. You can write that Parquet file back out to the Ceph Nano local object store, right here, running right here in my AnyShift environment. So it very much is you have this kind of same operational modalities between using Ceph as an object store and then Amazon S3. So if developers are used to having the experience in the public cloud and you want to replicate that private type environment, it's really relatively seamless for them to experience. Here there's another bucket of mine called BD Dist. I'm doing the same thing I did up here with the RAD Analytics. Figure it to that bucket to be pointing to Amazon, and I'm again using the credentials provider. And we have a trip report, a tab separated value, where at Red Hat we have, this is actually from Sherard's Data Hub team, the trip report is like a sanitized version of the reports that customers provide after a trip. And one of the things they do with it, and this notebook has further on down, is doing sentiment analysis, or building a model, training it, and then saving that model. And so this is kind of the data that we're sourcing there. So this is what this command does, is it's reading the sample data out of the bucket that's in Amazon. I can go away so I can read it. So it's reading the data, out of the bucket in Amazon, and then turning in CSV and turning it right around and then writing it into the Ceph Nano, running in our cluster, so that it kind of an example of almost like an ETL, except it's the same format. you can do something similar where here, you can read a CSV file in from Amazon S3 and then write it out to your Ceph cluster in a different format like Parquet, kind of all in one little neat command there. So that's kind of fun. An example of taking the RAD analytics, building on the RAD analytics tutorial they had available. Kind of, you can show the schema going back to the data frame 1, which was this end of day kind of ticker data here. You can kind of count it, or you could register the table. If a lot of data, folks that are analyzing data are familiar with using SQL, so they just want to use raw SQL and are less familiar with using kind of the Python methods for manipulating data, they can certainly do that. So by registering the data frame as this table name, now I can kind of just run Spark SQL against that table. We'll filter out just the ticker data with the red hat symbol here, and then plot it with matplotlib. And this is all from the RAD analytics example. Kind of taking the next, one of the things that the Data Hub team, Sherrard and company, were doing were analyzing data that was stored in their local Ceph object store. So, this Ceph bucket and Ceph Nano, I can kind of load the sample data set into a data frame. And luckily I already installed those in the kernel, so those are good. Load into the data frame this tab separated data, and this is coming from the Ceph Nano. It's stored in there versus Amazon S3, and you don't have to worry about PVs or moving data around there because it's in the object store. So if your post goes away, the data's still there. And the same is true after at the end of this notebook. I'm probably not going to probably stop here in a second, be able to get all the way through it. But saving the resulting model and tokenizer and feature dimensions back into S3, and then it persists. I don't have to worry about reattaching that PV to something object store that's available to anything that has the appropriate credentials, and is really kind of a neat way of kind of sharing data across multiple. You kind of have a shared data context across different applications, teams, or technologies, kind of thing. But yeah, the rest of the notebook kind of walks through taking the data that we flirted out of the Ceph Nano, and then I didn't write this. This was from the folks on Sherrard's team, but basically they train a machine learning model using this data, and then eventually out some charts and save it back into the Ceph cluster. Walk through a couple. So they're kind of showing the sentiment of these trip reports, based on the person, successful versus unsuccessful. And these are the sanitized, made up kind of people's names, and then breakdown based on the personality, the audience, whether it was customer or engineering, et cetera. But yeah, I have 10 minutes left, so I'm going to stop and kind of just answer questions. I'll send the link to the GitHub repo into the chat, and then I'll save it into the the SIG meeting notes also. So that